Can you see my screen?
Yes,
Yes.
sir.
All right. So in the previous class, basically we introduced our idea of vector and scalar and different type of vector, and also we talk about vector law, which is basically the vector triangle law. Then we also extended that idea for more than 2 or 3 vector. How we are going to find out the resultant using the vector triangle law, right? So fine. Today I'm going to talk about that mathematical representation of the vector. So in previous class we basically discussed about the graphical representation of the vector. Now today we are going to talk about the mathematical representation. To express that mathematically, basically a vector, we need idea of unit vector, right? Since when you write a vector, say a, if you say it's a 2y plus 3j, that's actually we are expressing that vector in terms of unit vector I and j in the Cartesian coordinate system, right? That's actually that for two-dimensional case. If it's one-dimensional, it will be only twice I. If it is three-dimensional, there will be one more dimension over there, or the axis. That's fine. So now the question is, what is unit vector? Do you have any idea? How do we define the unit vector?
Yes, sir. Can I?
Yeah, sure.
So if we divide the vector with its value, then we can get the unit vector.
Yeah, that's fine. That's the definition of the unit vector. That's good. Very good. But say, uh, if I write the vector A, actually say that the 2i. When you write down the 2i, basically what is telling you or what comes in your mind?
Sir, maybe it's saying that it is going 2 units to the x direction.
Exactly. Good. Very good. So that's mean I have to go the two smallest unit towards the x direction, right? Towards the positive x direction, because we express the I hat is the unit vector in the direction of the x, positive x. That's mean without that I hat, the 2 is basically the scalar quantity. This unit vector is telling me moves towards the positive direction. But how much unit? 2 unit. Now, how do I define that 2 unit? Should I, someone remove, say, I consider this the 2 smallest unit box, because I consider the smallest unit box basically the 1 unit. Someone can say that no, I will consider 2 unit, 2 smallest box is 1 unit. Then we have to move in that way, right? Because this is that, in that case these 2 boxes will be 1 unit and these 2 boxes will be another 1 unit. This added total, it will be the 2 unit. That's mean this unit vector for is basically the smallest unit in your some reference frame or reference axis, and by default we consider this smallest unit would be basically the 1 for Cartesian coordinate system, right? We say that the magnitude of this unit vector basically the 1. That's fine. That's going to be the 1, because that for our only for the for our calculation purpose. If we can separate, say we can consider for this is with a half is the smallest unit. If we can consider, then we can write down, because it's not always true that the unit vector magnitude will be always 1. That's not always true. Say, for example, you define that unit vector, vector by vector magnitude, right? I want to find out a unit vector in the direction of vector itself, A. That means if I want to find out the unit vector of vector A, that's according to your definition, it would be vector by vector magnitude, right?
Yes, sir.
and this vector actually the 2I hat plus 3j hat. And what is that? 4 plus 9 is going to be the root over 13. So is not magnitude is going to be equal to the 1. Right? It's not always true that it will be that magnitude will be 1. And this unit vector A is in the direction of vector itself. Say for example, vector A is toward that direction, then A head would be also toward that direction. That's the definition of unit vector. We can find out vector by vector magnitude. But for Cartesian coordinate system, we express that vector by unit vector actually I, z head, and the k head. It's a convention they follow, and its magnitude is a 1. This is the smallest unit they consider as a 1. Sometime you will find out instead of I head, we can write x head, y head, and z head. Right? Sometime you will find out they use symbol in that way. Or sometime you can also find out it's a E1 head, E2 head, or E3 head also in Cartesian coordinate system. Basically, this is actually the notation, nothing more than that. So don't be afraid actually if you somewhere find out the unit vector they express in that way, because different coordinate system has a different unit vector. We'll talk about say the polar coordinate, Cartesian coordinate. Cartesian coordinate you are already familiar with, but the polar coordinate and spherical coordinate and the cylindrical coordinate system also different coordinate unit vector. All right. Now this unit vector actually say help us to express the vector mathematically, right? Say for example, I have a vector in the two-dimensional case. I'll first talk about two-dimensional case, then I will extend that idea for the three-dimensional case. Say this is my Cartesian coordinate system, x and y axis. Say this is a origin, and I have a point. Say that the P is over there, and the coordinate of this point say that x and y. And I want to express this vector say that which is OP by a symbol letter say that A. It means that OP vector equal to that A vector. I need to express that one. So in general, you can say that that vector will be basically x I head plus y z head, right? But how do we write down this one? Is we write in a way like one moment, guys. There's some issue. Right. So this could be written as look at this. If you want to reach that point P, probably you have to move some length towards this x-axis, which is x, and some length towards this y-axis, right? Which is length is y. But if you multiply this x with I head, you will find out this vector. If you multiply this y with j head, you will find out that vector, right? Now, if you closely observe over here, these two vectors are head to tail connection. Now I can apply my vector triangle law. If I apply my vector triangle law, it would be x I head plus y z head. That must be going to the vector A, right? We find out using that only the vector triangle law over here, right? So that's mean vector triangle is very important. I say to using that one we can every time I'm going to use this vector triangle law If you want to find out anything over here, we are going to basically use this vector triangle law. It's a very useful law actually. That's why I said that one. All right, fine. Now, what about say in the three-dimensional case, you can also express that vector in a way. If it's three-dimensional case, we'll express that vector in x I hat plus y z hat plus z k hat, right? We'll see that one also, how you're going to find out. It's exactly the same way we'll express step by step, then you will find out. That would be actually the case for uh, the three-dimensional case. All right. So that's how actually we express that vector in Cartesian coordinate system in terms of unit vector I, j, and k. Now let's talk about some properties of this unit vector. Properties of unit vectors. So if you have two vectors, say that unit vector I plus I will get twice I, right? Just when they are in that same direction, then you will find out basically double of that. This will be twice I. If you subtract this I and minus I, that's going to be the zero, right? So in that case, they are in that opposite direction. So this is the I and this is will be also I, but in the opposite direction. You can say this is actually the minus sign. You will find out zero in that case. So that's when if they are parallel or anti-parallel, in that case actually we can add them or subtract them. If they are not, say if they are in the different direction means is say that they are, if they are perpendicular to each other, we cannot add. Say if that one vector is toward that direction, another vector is toward that direction, in that case this is I hat and this is j hat. In that case we'll write down this will be basically I plus j. Fine. Now, what about, say, if I write I dot I, the multiplication, what will be that value?
1.
It will be 1, right? Fine, but how does it become 1? That's the thing I'm going to talk about over here. So, look at this. I'm going to use that formula actually. You are familiar with this dot product of the two vector. If the two vector are A and B, then we can write A dot B is basically AB cosine theta, right? I know all of you know this formula. I'll talk about this thing elaborately when I'm going to talk about the multiplication of the vector probably in the next week. So where AB actually the magnitude of vector A and B, and theta is the angle between the vector A and B. Using that idea, we can write it over here. So magnitude of I is 1, magnitude of I is also 1. Now what is the angle between I and I vector?
0 degree.
0 degree.
It's a 0 degree, right? So that's why I'll write down the 0 over here, and cos 0 basically the 1, it become 1. By the same analogy, you can say that j dot j equal to k dot k and equal to I dot I. That would be basically the 1. Fine. Now, what about if I write I dot j?
0.
0, sir.
Why is 0?
The
Sir,
triangle is 90
The
degrees.
result is 0.
because I and J are in perpendicular, so the theta will be 90 and cos 90 is 0.
Cos 90 is 0, right?
Yes, sir.
Yes, sir.
So that's why. So if you write in that way, so I dot j, the angle between these two unit vector is 90 degree. So I'll write say 1 into 1, but the cos 90, that's become actually the 0. So that's mean I dot j, j dot k, and k dot I, that's become actually the 0. So you have to carry this information somehow in your head actually. So I said in another way actually, if the similar identities actually they survive, because I dot I is a similar, j dot j and the k dot k, they are similar. Similar identities will survive, but the dissimilar identities I dot j, j dot k, and k dot I will be vanish. Fine. Now what about say that I cross I?
Sir, 0.
I cross I is also the 0, right?
Yes,
Yes,
sir.
sir.
Yes,
So
sir.
yeah, so that we are going to find out using that cross product formula, a cross b, actually that ab sine theta into eta hat, right? Remember I use another notation over here, eta hat. This eta hat is also a unit vector, and that unit vector must be perpendicular on both a and b separately. It doesn't require that AB would be perpendicular, but a eta hat must be perpendicular on both A and B. Say this is your A and B vector in say in XY plane. Then eta hat would be either upward direction, which would be perpendicular, or it could be in the downward direction. That would be also the perpendicular. But which direction it would be, that you have to find out using that right hand rule. We'll talk about this thing. So using that idea, we can write this thing would be I magnitude is 1 into 1 into sine 0 degree. Sine 0 is 0. That's become actually that 0. So that's why I cross I equal to z cross z equal to k cross k. That's become actually that 0, because angle between them actually the 0. So that's why they become 0. Now what about I cross j?
1
1, sir.
1, sir.
K.
K.
सर सर क्या होगा?
Oh,
Look at this. So this one I said you say if you consider this magnitude is 1, j magnitude is 1. Now the angle is sine 90 degree. Now what would be the eta head over here? I say when you write down a cross b, this eta head must be perpendicular on both a and b. If you think about, this is your I, this is your j, then k head would be only that could be perpendicular to that both I and j. It could be plus k or the minus k. So that's why this eta head over here would be that k head, and this sine 90 actually become 1. So that's why it would be that k head. It means that I cross j would be that k head. So you can get this information in another way. Actually, I did in that way. I, j, and k, I write in that way. Remember, any angle we measure from positive x-axis, counterclockwise direction is positive. If we move counterclockwise, it will be positive. But if we move to the clockwise direction, that would be negative. It's a convention. We will also follow that convention over here. Now, when you write I cross j, basically you are moving to the counterclockwise direction. So that's why the resultant would be plus k. But if you move j cross I means this one, you are moving to the clockwise direction, it would be that minus k. So that's how you can write, say that I cross j equal to that plus k, j cross k, that would be that plus I, and k cross j, k cross I, k cross I, that would be that plus j. But if you move in the reverse way, so that's been clockwise, k cross j, that would be basically minus I. This is actually that properties of this unit vector, we have to carry this information somehow in our head. I know all of us, you definitely know this one, but sometimes you make a mistake, which shouldn't be in this level. It would be unfair if you make a mistake anything doing this multiplication or to express that vector in terms of I, j, and the k in the unit vector. That's why I introduced that thing again over here, because this is actually that rudimentary thing to deal with the vector. If you have any confusion, please go through these topics again and try to overcome your, try to clear your confusion on this unit vector.
Sir,
Yeah.
sir, how can you explain again how I cross J become K?
All
I
right.
didn't understand the first.
So are you familiar with this one, A cross B, actually, that A, B sin theta, right?
Yes, sir.
Into eta head. And
Yes.
this A cross B is a vector. That means it's required magnitude and the direction. This one is the magnitude, and this eta head will give you the direction, which direction it would be.
Okay, sir.
And this eta head, remember, would be always perpendicular, both A and B. Now, when you deal with this unit vector I and j, this is my I and this is my j. When you write taking this I cross j, I know the magnitude of this one is 1, right? This one is 1, and the angle is 90 degrees, sine 90 degree. That's magnitude, give me the 1. That's fine. Now, what would be the direction? Direction, I say this is the eta head will give you the direction. And direction you can find out actually using the right hand rule. What that rule? You have to put in your forefinger or the index finger towards the first vector and rotate it towards the second vector, right? Do you know that one? So this is actually, I'm going to draw, this is your index finger, this is your thumb, this is your index finger, and this is other finger of you, this is your hand. You have to place this finger towards the first vector I and your palm towards the second vector. When you rotate from first vector to the second vector in that way, then your thumb will give the direction of your resultant vector. This is one procedure actually you are familiar with to find out the direction of the vector k. But another way I describe in that way actually say this eta head is be perpendicular both I and j or a and b in this case. Now for I and j, the k is perpendicular. K head is perpendicular on both I and j. So that's why I say that this is would be the k head over here. And that's we can find out using a shortcut idea. I say this is the I, this is the j, this is the k. If you take that I cross j, if you move to the counterclockwise, I cross j would be the plus k, j cross k would be the plus I, k cross I would be that plus j, because I'm moving to the counterclockwise direction. But if you move to the clockwise direction, it would be negative.
Okay. I understand.
All right, is that okay?
Yes, sir. This is clear now.
Yes, sir.
Fine. Let's talk about that component of a vector. Component of a vector. So component is basically the projection of a vector towards some direction. Say, for example, I'm going to talk about two-dimensional case, which is easier for us. Then we'll also extend that idea for the three-dimensional case, step by step. Say, this is a vector. So I have that vector, say this is my x-axis, this is my y-axis, and say this is my vector A. Right now I do not know that coordinate. I just know the vector A. And this vector created some angle over here, say that theta. And generally we express that vector in a case which is actually a x I hat plus a y j hat, right? You're familiar with that for the two-dimensional case, where ax and ay is basically component of that vector along to the x direction and along to the y direction.
Yes, sir.
Now, what is that, or how do we write down that one? That we are going to talk about over here. So first, I'm going to show you how we can express this one. Say, if you put on a light onto that vector, you will find out the shadow of this vector A into the x direction, right? Say, this will be your shadow. You understand? If you put on a light onto that vector, you will find out the shadow of this vector A into that x-axis. That is actually component of this vector A in the x-axis. The same thing for also the y-axis, or you can say the projection of vector A along the direction of x. Now we will express this thing would be ax, and in the y direction that would be, say that ay towards that one. Now if you multiply this ax with I hat, I'll find out that vector. If you multiply with ay with z hat, you will find out that vector. I'm going to shift that vector ayz from here to here. This is actually new position of ayj, and these two vector again head to tail connection. Then definitely I can write my vector triangle law: ax I hat plus ay z hat. That's going to be my resultant vector A. That's how I actually express the vector in the two-dimensional case. Now, how I'm going to find out this ax and the ay? That one, that's actually our target, the component. Look at this. If you want to find out the component of a vector, always you have to take that cosine ratio. Never think about that sine ratio. Sine ratio is automatically give you. If the axes are perpendicular, then that perpendicular direction will give you actually sine ratio, sine in terms of sine actually. But that's if the axes are not perpendicular, then the issue would be basically the different. So that's why if you take that component as a sine ratio, it would be wrong. So that's why it's better, or it would be wise decision to take the component always in terms of cosine ratio. So if you have a vector, if you know the angle, the direction you want to take the component, then always take the cosine ratio of that angle to find out that component of that vector into that particular direction. Never think about that sine ratio. For this case, look at this. This is my vector A. This is the angle theta. This is my AX. This is my AY component. It's a right angle triangle, right? So this is actually that 90 degree. And this angle would be 90 degree minus theta, because axes are perpendicular to each other over here. Then if I want to find out this AX component, I'll write down cos theta, because this vector A create an angle theta with this axis towards that direction, x direction, and that component actually I label by AX. I want to find out that value, AX. Then cos theta is we will define the base divided by hypotenuse. Hypotenuse is the A. This AX and the AY, and the A is basically the scalar over here. I take the magnitude of that one. Then in that case, AX would be a cosine theta, right? Just we know that one. That's fine. Now what about, say, Y component? Y component actually create an angle 90 degree minus theta with the vector A. Then I write cos of 90 degree minus theta to be base, which is AY divided by A. That's give me actually that AY A cos of 90 degree minus theta, and cos of 90 degree minus theta is basically sine theta. You can write down using that trigonometric properties. right? That's how actually you can find out the component of vector. Fine. What if, say, instead of that vector create a angle with that y-axis? So instead of x-axis, is create the angle with the y-axis right now. So this is your vector. This is your, I'm sorry. This is actually x-axis. This is actually y-axis. This is my vector A. Now let's create an angle over here, theta. Now I need to find out that component. If you take the projection, you will find out, look at this. This is will be actually your AY, and this is will be your AX, because AX will be over here, but I shift that one. Then you can draw this right angle triangle over here. So this is your angle theta, this is actually A, this is actually your AY, and this is actually your AX. This angle is 90 degree, this angle is 90 degree minus theta, 90 degree minus theta. So if I want to find out the AX, then I will, because this AX create an angle 90 degree minus theta with that vector A, then I will write cos of 90 degree minus theta would be base, which is actually that AX divided by A, and this will give you AX would be a cos of 90 degree minus theta, which would be AX would be, in that case, a sine theta, right? And a y would be, which is create the angle theta with the vector A. I'll define cos theta to be base. Base is AY divided by A. I'll write AY would be a cos theta, which is completely opposite of the previous case. Right. So that's mean when you think about for component of a vector, always you have to consider with that cosine ratio. Never think about the sine ratio. Sine ratio will automatically give you. Look at this, every time I'm defining in terms of cosine, I just look at the vector, I just find out the angle the vector is created towards some direction, which direction I want to take the component, then I take that cosine ratio in terms of that definition of trigonometric definition. By the trigonometric definition, I find out that component. All right, let's think about the three-dimensional case. So this is the case. This is a vector A. This is my say that x-axis. This is my y-axis, and this is my z-axis. Say that vector create the angle theta with the z-axis. Now I'm going to find out the component of that vector. So I have to take the projection. I'm taking that. So fine. So I can say this will be my z component of vector A along the z direction. This will be my ax component, and this will be my ay component, right? Fine. I can find out the az directly, which is easy, because if I draw that triangle over here, because this angle is 90 degree, this angle is theta, this is the vector A, and this is my AZ component, right? You can draw in another way. If you think about, say, this is actually another way. So if you extend that idea, so this is, I draw in another perspective basically. This is your 90 degree, this is your vector A, this is actually theta, and this is actually that AZ component. Then you can find out in terms of cos theta. Cos theta would be base actually that AZ divided by A. So which give me actually that AZ actually A cos theta, because it's create an angle with the Z axis actually cos theta. And this vector would be A would be basically AX I head plus AY Z head plus AZK head, right? Should I show that one? How it become that way? It's required to show that one, how the vector would be AX I head AY Z head plus AZK head. Should I show that one? Hello?
So I didn't understand your question, sir.
The question is, should I show that how this vector become AXI head plus AYZ head plus AZK head?
No, sir.
No,
That's fine.
sir.
That's good. Because I shown in from the two-dimensional case. Three-dimensional would be the same. Actually, take the projection or use the vector triangle law step by step. You can find out. That's the. All right, fine. So I find out that AZ component. Now, look at this. I have to also find out the AX and AY component, right? So to find out that one, I know this angle is 90 degree, right? This angle
Yes,
is
sir.
theta. Then this angle would be 90 degree minus theta. Then I can find out the projection of vector A in the xy plane. I write, which is actually that AXY. I write down the subscript as a XY because this is actually that projection in the XY plane. So that's why I write down AXY. XY actually indicating the projection of vector A in the XY plane. Or you can say the component. Then I can write down, I'll write down again, cos 90 degree minus theta would be base, which is AXY divided by A, right? You can draw this diagram. So this is actually your the angle, which is creating this one. It's a 90 degree minus theta. This is the angle. This is the vector A, and this is actually that AXY. Then it's become actually, look at this, it would be AXY would be A cos of 90 degree minus theta. That become actually that A sin theta, right? So that's mean AXY, the component of vector A in the xy plane would be basically over here is sin theta. Because they are perpendicular to each other. So that's why it becomes a sin theta. I have to use that one. Now look at this. Now say, think about this AXY is create a angle with that x-axis is phi. This angle is the phi. If this phi, then this one would be 90 degree minus phi, right? Now I'm going to find out. Yes, any question?
No, sir.
All right. Now look at this. I'm going to draw for you. Say this is the case. This is your AXY is create an angle the phi over here. This is actually your AX component, and this angle is again the 90 degree. Then I will define cos phi to be base, which is AX divided by hypotenuse, which is AXY. Then I can write ax would be a xy cos phi. And I know the value of axy. I find out which is actually a sine theta into cos phi. So that's why your ax component would be a sine theta cos phi. That will be the procedure to find out the component of a vector in the three-dimensional case. And my request is please do not try to memorize this thing. If you memorize, definitely you are going to make a mistake. This is the process actually I'm taking.
Did I get deceived?
স্যার চলে গেছে।
ও আচ্ছা।
ডিসকানেক্ট হয়ে গেছে স্যারের।
তো বন্ধুগণ কেমন কি অবস্থা সবার?
এখন অবস্থা বলবো না, রেকর্ড হয়ে থাকবে, পরে বলবো। মেসেজ দিস
সবকিছু মাথার উপর দিয়ে যাইতেছে।
ওই বেটা এসব বলিস না, রেকর্ড
আয়
হচ্ছে।
হায়
রেকর্ড
রেকর্ড।
আরে আরে মাথার মধ্যে ফিজিক্স করে আর মনের ভিতরে তুমি।
আকিদ রেকর্ড হচ্ছে।
ও সরি সরি। স্যার চলে গেল।
দাঁড়াও,
স্যারের
না,
মেয়ে
এটা
আমরা
টাইম চলে গেছে।
এইটা যদি
হয়তো
রেকর্ডে
হয়তো
হয়, সাত তো চলে গেছে, তাহলে তার রেকর্ড হওয়ার কথা না।
না,
না,
রেকর্ড
এখন তো record
অন
হবে
করে
না।
গেছে স্যার।
রেকর্ড
না,
স্যার
record
হচ্ছে রেকর্ড
এই যে
হচ্ছে।
ও আচ্ছা রেকর্ড
হচ্ছে
চলছে,
তো।
রেকর্ড হচ্ছে।
অনলাইন ক্লাস এগুলো বোঝা একটু কষ্ট।
Hello.
স্যার আসছে।
Yes,
Yes, sir.
there's a issue from my side actually. The network issue. All right, so we're talking about this thing, right?
Yes, sir.
All right, so we find out this ax component. Now, what about say that a y component? So to find out the a y component again, we'll use that step by step. For the a y component, look at this. This one I have to draw. So this is actually your a y component. This is actually your vector axy. This angle will be 90 degree. Remember, this angle will be 90 degree over here. This is actually your axy. This is actually your ay. This angle is 90 degree minus phi. So if it is the case, then I will write down again cos of 90 degree minus phi would be base. Base is actually that ay divided by axy. Now I can write this ay would be axy. Cos of 90 degree phi actually would be sine phi, right? And axy actually that is sine theta. So then I can write ay would be a sine theta into sine phi. That how actually you can find out that component of this vector in the three-dimensional case. That is the procedure to find out the component in the three-dimensional case. If it is create the angle with the theta in any axis, say if the vector create an angle with that x-axis, since I do not know that one, so that's why I have to take the projection. If I know that angle between the vector a and x, I can directly find out the projection, right? And that's how actually we can find out that angle actually. So that would be the procedure actually to find out the component of vector in three-dimensional case. You can find out using the idea of the vector component step by step. Is there any question over here?
I don't
Hello.
think so, sir.
No, sir.
No, sir.
Those who asked me about the sample problem 4, now is it clear to you?
Yes, sir. It's clear
All
to
right.
me now.
Yeah, that's good. Fine. Now let's think about for say that I don't know how much time I can give you because there is a issue in my side actually. They announced yesterday, DPDC tell us that there will be no electricity in this area from 9 a.m. to 5 p.m. But still, I am lucky they started from right now. So I have the backup of my laptop, but I don't know how much time there will be. But I'll probably I'm going to take not more than 15 minutes actually. Within 15 minutes or 20 minutes, I have to finish today's topics actually. Anyway, I'll try because right now I'm running this thing with the generator support in my apartment, and they can give me support not more than 1 hour. All right, let's think about for the polar coordinate. So for in the Cartesian coordinate, we express a vector in terms of that, right? We express ax I hat plus ay z hat plus az k hat, right? That is actually that convention in the Cartesian coordinate system where ijk actually the unit vector in that Cartesian coordinate system, and ax ay actually and az actually the projection or the component of vector in the x y and z direction. That's fine. Now, if you want to express a vector in the polar coordinate, we have to understand that polar variable. And we know that the polar variable is basically r and theta, right? Do you know
Yes,
polar
sir.
variable or polar coordinate? So is basically
Yes,
the
sir.
two-dimensional
Yes, sir.
case. So this is a case. Say you have a vector and then coordinate of that point, say x and y in the Cartesian coordinate system. So this is your x-axis. This is actually your y-axis. And if is the vector is r and is create an angle the theta, then in coordinate in the polar form of this point, we can write it with that r and theta. Right? This thing you already know that one. And we can make a relation with r and theta because that r vector I can express in a x I hat plus y z hat using the vector triangle law, because if you want to locate that point, this is would be your x I hat because this is the x length. If you multiply with that I unit vector, you will find out that vector. Similarly, this is it would be your y z hat, and you will find out that would be basically x I hat plus y j hat. That's fine. Now you can also find out that component of x. This x would be is basically r cos theta, and y would be basically that r sin theta, right? We use that idea same for component idea over here. So this is actually your r, this is actually your theta, this is your base, and this is actually y length. Actually, you can find out this from the cosine ratio. Actually, cos theta would be x over r, and that's why x would be the r cosine theta, and for y it would be 90 degree minus theta. Actually, cos of 90 degree minus theta would be y over r. Then this it will give you that y will be the r sine theta. And we can also find out that magnitude of this r from there if you square, or I can write another way so that you can understand. What I'm going to do, I'm going to do actually basically take, sorry, this is x and y. If I square on both sides of these two equation and add them, x square plus y square would be r square into cos square theta plus sin square theta. and cos square theta plus sin square theta is basically the 1. So that's why r would be root over x square plus y square, right? This is the magnitude. And the angle theta, which we express actually that tan inverse y by x, right? This formula is familiar to you. Remember, when you're measuring this angle, you are referring from x to y axis. Remember this one. This is a very crucial point actually, because we count down angle from positive x-axis counterclockwise would be positive, but the clockwise would be negative. If you say a particle is moving 30 degree towards the 30 degree, then I will assume that you are referring from positive x-axis by default. That's the confusion actually. So that's why when you say some angle, the particle moving 20 meter per second, making an angle 30 degree, that's mean I'm referring from positive x-axis, unless I mention the axis. So that's why the angle must be counted down from always positive x-axis counterclockwise is positive and the clockwise is negative. We will also follow that convention over here. Now I have to find out that unit vector in that polar coordinate. In the polar coordinate, the unit vector is basically, we express r hat and the theta hat. Like that Cartesian coordinate, we say that one I hat, j hat, or the k hat, or it was could be also represent x hat, y hat, or the z hat. Since the polar variable r and theta, so that why we express r hat and the theta hat. Now I have to find out that value of this unit vector. For that one, say I'm going to draw it so that it will be easier for you. So this is the axis, and say this is my vector, the r. This is my x-axis, this is my y-axis, this is my vector r, and let's create an angle, the theta over here. Now first I'm going to find out the direction of this unit vector r hat and the theta hat. That would be my first job. Then I will find out the magnitude of this one also. All right. Can you say what was the direction of I hat and the j hat in the Cartesian coordinate system?
So x and y.
X and y axis.
In the positive direction, right?
Yeah,
so
in the positive direction, yeah.
This is actually the I hat, and this is actually z hat. So if you closely observe, this I hat and the j hat is basically in the incremental direction of the x, or increasing direction of the x and y respectively.
Yes,
Am
sir.
I right?
Yes, sir.
So that means
Yes,
towards origin, from the origin x is increasing towards that direction, and y is also increasing towards that direction.
Y direction,
That's why
yeah.
the direction of I and j in toward that direction. Using that analogy, I can say the direction of the r would be in the incremental direction of the r. That's why this would be the direction of the r hat, and the incremental direction of the theta hat. Incremental direction of the theta, because theta is increasing towards counterclockwise, right?
Yes, sir.
That's
Yes,
why
sir.
r hat would be towards in the increasing direction of the r vector, and theta would be towards the increasing direction of the theta, which is counterclockwise direction. So that would be the direction of unit vector r and theta hat in the polar coordinate system. Fine. Now I'm going to find out that value. Say if that point is, say that the coordinate of that point is x and y, I find out that vector actually r was x I hat plus y z hat, right? And we
Yes,
also
sir.
find out x actually that r cos theta and y actually that r sin theta, right? Now I'm going to find
Yes,
out
sir.
that unit vector r, we define that definition. Unit vector r would be vector, which is vector r divided by vector magnitude. That's the definition. We already know that. For any unit vector, we can find out. The vector r, we already find out, which is x I hat plus y z hat divided by magnitude of r. I write simply r. X I write down r cos theta I hat plus r sine theta z hat divided by r. I can factor out, I can cancel out basically that r from both numerator and the denominator, right? So in that case, my r would be basically, r hat would be basically cos theta I hat plus sine theta z hat. So this is would be the basically that unit vector r in the polar coordinate system in terms of Cartesian coordinate system, because you have to use a reference frame. Actually, we are using that reference frame Cartesian coordinate system because uh, that is actually the familiar with us. We are very much familiar with that Cartesian coordinate system, or it could be vice versa. That could be done actually. We can write down, say, I and j in terms of also r and theta. That could be done. That's what we talk about actually in the classical mechanics. Actually, when you transform from one coordinate system to the other coordinate system, how this actually that vector is going to be the change, what will be the orientation of that thing, which is very interesting. But up to that is enough for you actually, how we are going to represent that uh, unit vector in the polar coordinate system. That's fine. Now I'm going to find out that theta hat. How I'm going to find out theta hat? Theta hat, I could find out actually using that some analogy actually. Look at this. I can write this could be r hat cross k hat, a minus sign in front of that. How did I write down? Look at this. We have some properties I give you for that unit vector for in the Cartesian coordinate system. If you write down I cross j, that would be the k. If you move to the clockwise, then it will be negative, right? Same
Yes, sir.
analogy I can use for this one, because in that polar coordinate I have the two variable r hat, theta hat, and also there will be also the k hat. R hat actually the two-dimensional case. If you think about in your table, that's the surface which is two-dimensional, r hat and the theta hat. There must be one more axis in the perpendicular direction, which will be the z-axis. Right, there is a one more axis or dimension, you can say the time, but for the time being we are neglecting that axis actually, fourth dimension actually. So then look at this, I can write down the theta hat actually. I write in r cross k, or you can write down the k cross r, it will be the same. So since I write or you can write that theta hat could be also k cross r is the same. I write down the reverse way. That's why I write down minus sign, because I'm writing r cross k. Basically, I'm moving in the clockwise direction. So that's why I plug in the minus sign in front of that. So now look at this. If you write this one, you can keep the k over there. Now this r hat, I write over here. Look at this. This is cos theta I hat plus sine theta j hat. I just plug in the value of r hat. Now the theta hat would be cos theta is a scalar quantity. That's a factor out. It's a k cross I plus sine theta is a k cross j. I cannot reverse it. I cannot write down over here I cross k. I cannot write down the j cross k. That you cannot reverse this one for that vector product. But you can do that for the scalar product. It's not the same, right? I cross j and the j cross k is not the same direction. That would be the two different direction. It is not the same. A cross b not equal to b cross a. It's not. It's a anti-symmetric. It's not symmetric. But you can write down a dot b equal to b dot a is the same thing. Like if you multiply 5 and 6, or 6 into 5 is give you the same result, because that's a scalar quantity. But the vector quantity is cannot be the same. A cross b cannot be never equal to the b cross a, because they are in the two different direction. So that's why you cannot never write down over here, because k is the first vector over here. You cannot never write down I cross k. If you, then you have to give a minus sign over there. I can write over here, look at this. This is actually that if I write A cross B equal to, then I have to give a minus sign in front of that, B cross A. Then I can say that equal. Otherwise, I cannot say that one. So this is actually the properties of this vector, actually, vector properties or multiplication properties. All right. Now we can find out theta hat actually cos theta. What is K cross I? K cross I, K cross I, it will be that J,
J, sir.
right? It will be
Yes,
that
sir.
So
Z hat
J and minus
plus
sign I, minus sign
K
theta I.
cross J, yeah. K cross J is going to be that minus I, right? Sine theta into minus I. That's mean my theta hat in that case I can write minus sine theta I hat plus cos theta Z hat. That would be the unit vector in the polar coordinate system. Now, why I introduce this thing? If you want to express a vector in that Cartesian coordinate system, you express in that form ax I hat plus ay z hat. You know that the value of I and z actually the one. That's why we kept in that way. If I want to express the vector in that polar coordinate, I have to write is a ar is called actually that radial part of the vector into r hat plus angular part a theta into theta hat. That would be the representation of a vector in that polar coordinate. That's why you have to know the value of r hat and theta hat. That you can find out in that way. You understand where it
Yes,
is
sir.
Yes,
actually
sir.
why we're
Yes,
talking.
sir.
Now, can you say one question? Say I have a vector, any arbitrary vector in the Cartesian coordinate system. Now, if I transfer that vector from Cartesian coordinate to the polar coordinate, will the vector will be the remain same?
Yes, sir.
Yes,
So
sir.
I have a
Yeah.
vector. I have a vector in Cartesian coordinate system.
Yeah.
Now I transfer that vector from Cartesian to the polar coordinate system. Will the vector will be look like same?
Yes, sir.
Yes, sir.
Yes, sir.
Is it?
Yes, sir. We are just transforming.
Yeah. Then
So,
vector.
so
Yeah.
maybe
Go ahead.
the vector look like same, mean same angle, same way, but maybe not the value will be the same.
The values will be the same.
Values will be the same. That's it.
Values
Yeah.
will be the
Yeah.
same.
Values
That's
will
a
be
scalar quantity. Values will be the same,
values. Yeah.
but the orientation will be the different. So that's when vector
Orientation.
will be the different. Say you have a street, you are observing from, it's a relativity basically. So that's why it's interesting actually. If you transform, say you have a street, someone actually observing that is stick from say the Cartesian coordinate system. What was the orientation it was? But if someone observed from the polar coordinate system or spherical coordinate system, vector orientation could be different. That's when the vector is different, but the magnitude or the length of the scale or the stick will be the remain same because that's a scalar quantity. Scalar quantity will be the remain same. It doesn't care about which axis you are observing, but the vector will be the change because it will be change its direction. Right?
Sir, I think it's happened for its angle.
Yeah, it's happen to the angle definitely because angle will be the different angle is going to the change. If the angle is going to the change, your vector orientation is going to the change. So vector will be the change. All right, so that's how actually we can actually develop the idea for cylindrical or spherical coordinate system. I'm not going to show that one actually. That's enough for you actually. If you at least can transfer from one vector from one coordinate system to the other coordinate system, what would be the change actually? That's all for today basically. I'm not going to talk about more than this today. Do you have any more question?
Sir,
No,
is
sir.
AR equals to root over x square plus y square?
AR?
Yes, sir. The
No, no,
values of
no,
AR and A
no,
theta.
no, no, no. You have to find out that one.
We have to find out.
Yeah.
Oh, okay, sir.
You have to calculate that one because there is two part actually, radial part and the angular part. All right, if you don't have any question, you can guys leave. This is the end of this first week. See you in the next week.
Thank you, sir. Assalamu alaikum.
Assalam.
Thank you, sir. Assalamu alaikum.